Hi, let's get to the topic. Let's understand what is constraint satisfaction problem. So we'll take an example of Sudoku puzzle solving. So before jumping to that, we need to understand some of the concepts like simple backtracking, forward checking, arc consistency, and all. So let's jump on one, one after another. See, just what is mean by constraint is nothing but like kind of conditions. Just think that you are going to temple and like maybe you need not to wear anything abnormal, what to say, like any dresses. It should be like neat and clean, like something like that. Or you are going to marriage and you need to have specific attire, right? So that's what constraint in a simple language. So for same to solve any problem, we'll have any some conditions. So let's come to the puzzle problem, Sudoku puzzle problem. There is simple backtracking. So means just think that like see you are in a maze and if you want to what to say pass that maze and come through the maze, what you do usually like you try all options and at the end if you don't find anything, like if you get stuck and try to find another option like that only. So same way even computer tries to solve the Sudoku problem, right? So the next concept is forward checking. Just think that you are inviting what to say your friends and all, but before that like if you have any cookies or something or any of the food, you need to arrange, right? Arrange whether it is all the friends are enough or not, like for the cookies or whatever you have, uh, that should be sufficient, right? You check that like just a precaution kind of thing. Okay, third concept is arc consistency. So just think that you are giving a like I'm explaining kind of a to 10-year old kid. Just think that that kid is needed a candy. Okay, like the specific candy, mango flavor or something. So he just have many of the candies, but he just makes sure that his choice of candy is with him already. Means in this right, like this example, Sudoku making sure that when you place a number, all other squares can still be filled with valid numbers. So that's what arc consistency means. Okay, so this is again a CSP, what to say, solving techniques. Okay, another smart uh, choices or strategies are nothing but like minimum remaining values. So just think an example where like 10-year-old kid is solving the homework. So try to solve hardest first and then the what to say like much more easier one. Okay, computer also does same thing almost. So computer looks for squares that have fewer possible numbers that could go in them. Okay, so this is kind of trickiest. So like computer looks for a squares that have the fewest possible numbers could go in them. Okay, so others, that means like other possibilities can be easily solved, right? So degree heuristic. Okay, so just think an example where like you have a very what to say like messiest room and the cleaning will start from the very messiest area, see, like that. So you, even in Sudoku, right, what happens when uh, what to say code is working or computer is working, that means it likely to see uh, middle, what to say, middle box or middle point where like connected to too many rows or too many columns in the boxes. Okay, So next concept is least constraining value. So just think an example where you have a Lego and you are solving the Lego puzzle. So what usually you try, like you try to find the common pieces first, then you save others for special ones, right? The same way computer chooses a number that keeps most possibilities open for other squares. Okay, so these are techniques, and like just think combining all these, like depending upon the what to say, whether it is easy or medium or hard, uh, what to say, the problem or a program should choose whatever concepts we have discussed. So when computer solves Sudoku, it should combine the techniques of either MVR or to say least constraining value or consistency based on that. Okay, so let's jump to the demo. Okay, so see, this is an example where like you see this, there is a two options here: generate a random puzzle based on whatever we select here. Okay, whether it is easy or medium or something. Every time I click on this generate new what to say puzzle, so there is a almost like 9 by 9 uh, new puzzle will be generated. Just notice it's getting changed every time I click on this. Okay, so the second part is basic backtracking. Okay, so here an example. So if I click on this, it is solved and how many iterations it took, everything is uh, like there also, like yeah. So the next part, as I discussed, forward checking, and with that what happens, so and even the arc consistency, and the last part, as I mentioned, when you have different scenarios, like based on this, right? See, hard and number of tests. See, like based on the selections, which one will give the uh, best result or like fast result, that it shows. So easy puzzles so are solved using basic backtracking or MER alone. Okay, and mediums needed the MER and degree heuristic. Hard and expert level needed full heuristic combinations. It can take anything. So if I just take to expert and just increase the test runs, you will observe like this will take a little bit more time, and also the time and iterations, everything will be a little bit more. Okay, so if you notice, it's more time is taken. Okay, so you notice like how much iterations it taken and time, so everything is there here. Okay, so next, so let's get to second CSP problem, that is genuine solver. So it's a again a one CSP problem. Just imagine like n number of uh, n cross n chessboard and same number of what to say queens are there. The problem statement is such a way that the each and every queen should be like alive. It should not be like killing each other, or there should not be conflict. Okay, so there are two concepts here: simulated annealing and hill climbing. Just think an example. Okay, you may be playing the what to say, there was toy, right? Like when we were young, like rings and rings in the water, and whenever you just press a button, like you can just put all the rings into that hook. Okay, so it's that game. Like sometimes how we play that, so randomly sometimes we just press the buttons and all the rings will go and sit in the what to say, that hook, right? So it's almost something similar concepts. Simulated annealing is nothing but the word annealing is a kind of a metallurgy word. Just think, it's like that, like when in a metal we heat to highest temperature and we cool down. So it's almost same thing. Okay, so here, what to say, randomly all options are, what to say, taken care, and it tried to solve. Okay, and this is a kind of the better solution than hill climbing. And again, you just think of hill climbing as, you need to identify local minimum, or a, what to say, in a hill. Just imagine you are on a hill and you are blindfolded and you need to identify local minimum. Sometimes you may stuck in a valley, correct? But like simulated annealing is nothing but it's can jump the valleys. So it's that concept. So again, some theory is there here also. Okay, just have a look. And so whenever, here is a app demo. So if you notice like what is happening, 69 iteration, every time I click on this button, right? See, number of conflicts, there are possibility of number of conflicts. We cannot say every time it will, the board will be solved. Okay. See, but again depends upon what is the initial position of the buttons, position of the queens. Okay, see now after 86 iteration, we found one solution. Okay, so again, like if you notice when I click on hill climbing, so the hill climbing is nothing but simulated annealing with temperature equal to 0. It's that kind. Okay, so see, after 10,000 iterations, also there is one final conflict. But if you notice, that conflict already came at, what is a second iteration only. So it's like kind of stuck in that, like local minimum. So it's like stuck in a valley. It's that kind of analogy I can just say. So just an imagine here, the hill climbing is nothing but one kid who is just eating a only one candy which is in front of him. But like that is not, he's not worried about the mountain behind him or something like that. So whatever is possible, it tries that. But here also, like, there are, again depends upon what is the, mm, see, again we got another good example where there are no conflicts. So although you see that there is one conflict in the beginning, two conflicts, three conflicts, so but after that it's solved. So both are the solutions for N-Queen's problem, but the simulated annealing is much more better. That's what I see. Okay. Thank you very much for this. Uh, Thank you very much for there till here.